Good day, students. Welcome to Mathgotserved.com. In this clip, we're going to be going over how to divide exponents. Okay, we're going to be applying the quotient property of exponents. This standard is covered in Algebra 1, 2, and Pre-Calculus courses. Don't forget there are 12 practice problems at the end of this presentation that we'd like you to attempt in order to demonstrate mastery of the contents covered in this tutorial. If you'd like to gain access to our entire playlist and other valuable learning resources, you can visit our website at mathgotserved.com or just take a look at the link in the description below to gain direct access. To get us started, we're going to take a look at the formula that will be guiding our problem solving process, okay? So this is the quotient property of exponents. So if you're dividing exponents of the same base, x to the a divided by x to the b, this is equal to basically the difference of the exponents. So x to the a minus b, or this can also be written as, or if you have x to the a divided by x to the b, you can also write this as 1 over x to the b minus a. Okay, so the strategy we're going to be using here to save us from reciprocating is to take a look at the term, the exponential term with the bigger power. Okay, so whichever term has a bigger power, what you want to do is subtract the smaller exponent from that and then cancel out the smaller one, and that will be your final result. Okay, all right, let's go ahead and take a look at some examples. So the instructions are as follows. You're to simplify the following. Expressing all terms with positive exponents. Okay, so you cannot have any term with negative exponents. That will require simplification, further simplification. Okay, all right, so for question 1, let's say we have x to the 9th power. Want to simplify x to the 9th power divided by x to the 6th power. All right, so if we want to apply the quotient property of exponents as indicated earlier, we have x to the 9th divided by x to the 6th. So one way to think about it is that there's a battle going on between the term in the numerator and the term in the denominator. Okay, so whichever one has a greater power or exponent, that one will dominate and the other one will get taken out. So if you take a look at this battle going on here, you can see that the exponent in the numerator is 9 and it's bigger than the exponent in the denominator, which is 6. So what does that mean? All you do is you basically divide out the smaller the term with a smaller degree, which is the denominator in this case, so that divides out to 1. And what you do is you subtract its power from the power in the numerator. Okay, so that's going to give us x to the 9 minus 6, which is x to the 3rd power over 1, which is just x. All right, so there goes your final answer. All right, let's take a look at another example, number 2. Now let's say you have y to the 4th power divided by y to the 7th power. All right, so how do we simplify that? Expressing our final result using positive exponents. So we have y to the 4th over y to the 7th. Now, let's say that these two terms, one in the numerator and the denominator, go to battle. Which one has greater power? It's the denominator, right? Because 7 is greater than 4. So what are we going to do? Using the reciprocal property of the quotient property of exponents, you're going to subtract the smaller power from the bigger one, and then the smaller power completely gets reduced to 1. All right, it's just as though we're dividing the top and the bottom by y to the 4th power. And then your final answer will be 1 over y to the 3rd power. Now, had it been we use the first formula here for this problem, we'll have y to the negative 3 power, and then we'll just apply the reciprocal property of exponents, and then just reciprocate it to get this desired result. Okay, so the answer to number 2 is 1 over y to the third. All right, let's take a look at another example. Let's say we have m to the 8th power divided by m to the 8th power. All right, so the monomials in the numerator and the denominator, they are both identical in degrees and the bases are the same. So how do we deal with a scenario like this? So m to the 8th goes to battle with, it's something with identical power, m to the 8th. Who do you think is going to win? They're basically going to take each other out, right? So m to the 8th goes here once, and m to the 8th goes here once. So your final answer will be 1 over 1, which is just 1. Alrighty? Okay. Now let's take a look at another example, question number 4. What if we have to simplify 12x to the 8th power? Now we're throwing in coefficients, okay, divided by 4x to the 4th power. Now, if you have coefficients, what you basically do is you divide the coefficients, all right? You don't subtract them. You divide the coefficients and you subtract the powers when dividing exponents with the same base with coefficients. Alrighty, so let's see how we're going to approach this one right here. We're going to divide 4 and 12. We know that 4 goes into 12 3 times, so divide the top and bottom by 4. If you divide the bottom by 4, you get 1. If you divide the top by 4, you get 3. That is the greatest common factor. Okay, so bring down the 3. And then for the variable, look at the x's. Okay, which one has more power, the numerator or the denominator? The numerator is clearly more powerful, so the denominator gets taken out completely. That's 1, and subtract its power from the numerator's power. And then you have 3x raised to the 8 minus 4, which is 4. So 3x to the 4th power is the final answer to question number 4. All right, let's take a look at question 5. So for question 5, what if we're to simplify, okay, let me see. A raised to the 3rd power, so we have a raised to the 3rd power, b raised to the 6th power divided by a raised to the 10th power, b raised to the 5th power. Okay, so let's say we were to simplify this. What will the answer look like? All right, so we have a to the 3rd, b to the 6th in the numerator, divided by a to the 10th, b to the 5th. Okay, so we're going to do the a's and the b's independently since they have identical bases. Okay, so now let's look at the a's. So if you look at a to the 3rd in the numerator and a to the 10th in the denominator, these two are going to battle, okay? So which one do you think is going to dominate? It's clearly the denominator, right? So what's going to happen is that a to the 3rd in the numerator will get taken out completely, divided to 1, and then you subtract that power from the denominator. Okay, so let me write it on the side so you can see exactly what's going on right here. So it's going to be a to the 10 minus 3, all right, using the quotient property of exponents. Now for the b's, what's the story there? B to the 6th and b to the 5th. We can clearly see that the numerator will dominate here, so b to the 5th in the denominator divides to 1, and then you subtract that power from the numerator, so it's basically b to the 6 minus 5, and the final answer for question 5 is b to the 1st power, the invisible exponent, over a raised to the 7th power. Okay, b over a to the 7th. All right, let's box our answer and take a look at the next one, question number 6. So for question 6, what if we were to simplify the exponent 15, the quotient of monomials 15x to the fourth, y to the third, divided by 3x squared y squared. Let's say we were to divide this out. Let's go ahead and figure out what the answer is going to be. Okay, so let's rewrite the question. All right, so let's look at the coefficients first. We'll divide the coefficients, reduce that, and then for exponents with identical bases, we just subtract the powers. All right, so 15 and 3, the greatest common factor there is 3. So if you divide the denominator by 3, you get 1. Divide the numerator by 3, you get 5. And then for the x's, the numerator dominates for the x's, so this divided out to 1, and you subtract that power from the top. And then for the y's, this one, the denominator has a smaller power, so it gets taken out to 1, and you subtract its power from the top, applying the quotient property of exponents. Final answer is going to be 5x to the 4 minus 2, which is 2, y to the 3 minus 2, which is 1. Okay? And then remember, you do not write the invisible exponent, which is 1, so you just write 5 x squared y. And that's the answer to question number 6. All right, moving along, let's take a look at another example, number 7. Let's say you were to find the quotient of the monomials negative 40, a raised to the 7th power, b raised to the 2nd power, divided by 10, a raised to the 7th power, b raised to the 6th power. All right, so how are we going to go ahead and simplify that? So write the problem, negative 40, a to the 7th b squared, divided by 10a to the 7th b to the 6th. All right, so we're going to divide the coefficients first. So let's see what happens. 10 goes into 40 4 times. So you can divide the numerator and the denominator by 10. So 10 goes into 10 once. 10 goes into 40 4 times. All right, now let's apply the quotient property of exponents in simplifying the variable terms. So for a to the 7th, we can see that they both have identical powers, so that they take each other out. You end up with 1. And then for the b's, look at the b's. You notice the denominator dominates here. So all we do is you subtract the power of the numerator, the smaller power, from the bigger power, and the smaller power gets taken out completely. Okay, it gets reduced to 1. So final answer, don't forget the negative, is going to be negative 4 over, and then b to the what? 6 minus 2 is 4. So it's negative 4 over b raised to the 4th power. And that's the answer to question number 7. All right, let's go ahead and take a look at question number 8. So for question 8, let's say you were to simplify negative 16x to the 7th power, y to the 10th power times z. If you're to divide that by negative 4x to the 2nd power, y to the 3rd power. All right, so let's go ahead and simplify that. So write the problem, negative 16x to the 7th, y to the 10z, divided by negative 4x squared y to the 3rd. All right, so let's divide the signs first. Since the signs are the same, anytime you divide signs that are the same, you always end up with positives. Okay, minus over minus, you just slash and dash. That's a positive right there. And then 16 and 4, you can divide top and bottom by the greatest common factor, which is 4. So 4 goes into 4 once, and 4 goes into 16 4 times. All right, so let's look at the variable terms. X to the 7 and x squared. The numerator dominates, so you subtract the power of the denominator from the top and divide that out, which is 1. And then for the y, it's the same thing. The numerator dominates because it has more power than the denominator. Denominator is divided to 1. You subtract that power from there. And the z has no contenders in the denominator, so you just leave it alone, okay? So our final answer is going to be 4, positive 4, y to the 7. Oh, sorry, I left out the x. So x to the 7 minus 2, that's 5. Y to the 10 minus 3. 10 minus 3 is 7. And then z to the first power, since it's the invisible exponent, we just write it like that. So 4x to the 5th, y to the 7z is the answer to question number 8. All right, let's take a look at question 9. So for question 9, what if we were to simplify 5n divided by 40n to the 13th power? Okay, let's take a look at that. All right, so we have 5n divided by 40n to the 13th power. So 5 and 40, what's a common factor? 5 goes into both. 5 goes into 5 once, and 5 divides goes into 48 times. Okay, so for the n's, if you notice, the n in the numerator doesn't have any power, so it has invisible power, which is 1. So these two are going to battle, okay? So which one dominates? Clearly the denominator dominates since it has a bigger power. So what you do is the numerator power will get subtracted from the denominator's power, and then the numerator will get taken out completely to 1, okay? So that's what you have. All right, let's multiply that out. In the numerator, we just have 1 times 1, which is 1. And then in the denominator, we have 8, and to the 13 minus 1 is 12. All right, so 1 over 8n to the 12th power is the answer to question number 9. Okay, let's take a look at question 10. So for question 10, let's say we have 24x raised to the 12th power, y raised to the 9th power. We have that divided by 72x to the 5th power, y to the 7th power. Okay. All right, so let's do it. So 24 x to the 12th, y to the 9th, over 72 x to the 5th, y to the 7th. All right, so let's look at the coefficients first. Do they have a common factor? The answer is yes, and that is 24. 24 goes into itself once, and 24 goes into 72 3 times. All right, let's look at the x's. X to the 12 divided by x to the 5th. The numerator has a greater power, so you just subtract the power in the denominator from the numerator, and then this one gets divided out to 1. And then for the y's, the same thing. The numerator dominates here, so the denominator is 1. Subtract that power from the top. And in the numerator, we're going to have x raised to the 12 minus 5, which is 7. Y raised to the 9 minus 7, which is 2. And in the denominator, we have 3 times 1 times 1, which is just 3. So x to the 7y squared over 3 is the answer to question number 10. All right, let's take a look at number 11. Number 11 is as follows. What if we were to simplify 28x to the 4th power divided by 2, the quantity 2x to the 7 raised to the second power. Okay, so in this particular example, we're not just using the quotient property of exponents, we're also implementing the power of a power property of exponents. Okay, all right, so how does that apply here? Well, in the denominator, we have a power raised to a power. So this parenthesis scenario has to be resolved first. If you think about your order of operations, please excuse my dear Aunt Sally, you deal with the parentheses first in exponentiation before you divide, right? So the same applies here. So in the numerator, we'll just have 28x to the 4th. And then in the denominator, this 2 will be multiplied by the powers of the power of the factors in the parentheses, okay? So 2 has an invisible power of 1. So this 2 will get multiplied by this 1. And then this 2 will also get multiplied by the 7. Okay? So that will become 2 raised to the first power. 2 raised to the second power. X raised to the 2 times 7, 14th power. Okay, so you're multiplying the powers. Let's simplify that. We have 28x to the 4th divided by 2 squared, which is 4x to the 14th. Okay, so now that we've dealt with the parentheses and the exponent there, we now have division, the division of these monomials to take care of. Okay, so we're going to apply the quotient property of exponents. Let's reduce the coefficients first. 4 goes here 1. 4 goes into 28 7 times. And then for the variables, x to the 4th and x to the 14. Which one dominates? The denominator dominates because it has a higher power than the numerator. So the numerator gets taken out to 1. And then you subtract its power from the denominator's power. And then your final answer, 7 times 1 in the numerator, you have 7 over in the denominator, x to the 10th power is the answer to question number 11. All right, so let's take a look at one more, question number 12. So for question 12, what if you were to simplify the monomials 3a to the 6th, b to the 3rd, this quantity raised to the 3rd power, divided by 54 a squared b to the 6th. All right, so we're going to start by getting rid of this exponent component in the numerator first, like we did in question number 11, and then we're going to go ahead and divide, applying the quotient property of exponents. Okay, so let's rewrite the question, and then let's see how we can get rid of that exponents and the parentheses in the top. So to do that, we're going to use the power of the power property of exponents. So this power will get distributed to the powers of each of the factors in the numerator. 3 doesn't have a power, so the default power is 1. All right, so what are we going to have? This 3 gets multiplied by the 1. This 3 gets multiplied by the 6. And then this 3 gets multiplied by the 3. Okay, so what does that give us? 3 raised to the 3rd power. A raised to the 6 times 3, 18th power. And b raised to the 9th power, which is 3 times 3. Okay, so that's known as the power of a power property of exponents. I bring down the denominator. The numerator's coefficient can be simplified further. 3 raised to the 3rd power is 3 times 3 times 3. 3 times 3 is 9, times 3 is 27. So we have 27a to the 18, b to the 9th, divided by 54 a squared b to the 6th. All right, so let's go ahead and reduce this completely. So 27 and 57 and 54 have a common factor of 27. 27 goes here 1. 27 goes into 54 2 times. Okay. Now for the a's, you notice that the numerator dominates, so the denominator gets taken out. You subtract its power, which is 2 from the top. For the b's, the numerator dominates again, so this gets taken out. You subtract its power from the top, and your answer is going to be in the numerator, a raised to the 18 minus 2, that's 16. B raised to the 9 minus 6, that's 3. Divided by 2. All right, so there goes the answer to question number 12. All right, now it's time for you to take a look at some practice problems in order for you to demonstrate mastery of the content we just covered. All right, so I'd like you to go ahead and try out these 12 practice problems. So what you're gonna do at this time is just pause this video presentation and try out these 12 practice problems. When you're done, click back on the play button, and then we're going to display what the answers to these practice problems are. All right, so hopefully you had a chance to try out these problems. Let's take a look at what the answers are. For number 1, the answer is 1 over x to the third. For number 2, the answer is k raised to the first power, so you just write it as k. For number 3 is just 1. For number 4, the answer is a raised to the fifth power b. For number 5, the answer is 3x to the first power, which you just write as 3x. For number 6, the answer is 2y to the first power, just 2y. And then for number 7, the answer is negative 8b. Let's rewrite this. So it's negative 8 over b to the sixth power. And then for number 8, the answer is 9x to the fourth power, y to the third, z. For number 9, the answer is n raised to the fifth power divided by 5. For number 10, the answer is 4x to the seventh, y to the fifth divided by 11. For number 11, the answer is 2x to the fourth over 3. And then for number 12, the answer is 9a to the 10th power, b raised to the 8th power, b raised to the 8th power. Let's write that again. So this is a to the 10, b to the 8th, and then the entire thing divided by 21. All right, so there goes the answers to our practice problems. So how well did you do on these practice problems? Let us know in the comment section below how well you did. If there are any problems that you need further clarification on, just put your question in the comment section below and we'll do our best to assist you. Thanks so much for taking the time to watch this presentation. Really appreciate it. If you found the contents of this tutorial helpful in your studies of exponents, to give us a like or a thumbs up. Your positive feedback is very valuable to us. Do not forget to subscribe to our channel for updates to other great math tutorials that we upload on a regular basis to our YouTube page. If you have any questions or comments, as indicated earlier, just put it in the comment section below. More support resources can be found at our website, mathgotserved.com, or you can just take a look at the link in the description below to access those resources. Thanks again for watching and have a wonderful day. Goodbye.